Today, we're diving into the 7 essential traits of the modern scientist. You see, the old image of a lone genius in a lab coat, well, that's a thing in the past. The skills needed today have totally changed. Let's get into it.
So when you hear the word scientist, what's the first image that pops into your head? Is it someone working all alone in a lab, surrounded by bubbling beakers and crazy equations? You know, for a long time, that was the classic stereotype. But as we're about to find out, that picture is seriously out of date.
And this comparison really nails the shift. The old idea of a lone genius kind of stuck in their own little silo, gone. Today's biggest challenges, they demand team players, people who can work across all different fields to make a real-world impact. The modern scientist is a collaborator, a networker, a systems thinker.
Okay, so what does it really take to become this new kind of scientist? We're going to break it down into 7 core traits, and we'll start with the 2 foundational mindsets that really form the core of modern scientific thinking.
First up is a trait you might not expect to find in a lab.
Creativity. Now, we're not just talking about abstract art here. In science, creativity is the engine for actual, practical innovation. It's about being able to work within real-world limits, like funding or technology, and still come up with new hypotheses and find totally new ways to test them.
And building right on top of that creativity is the second key mindset, a translational one. What does that mean? It means thinking way beyond the lab bench. It's constantly asking, how can this discovery actually help people down the line? It's about seeing the entire journey, from a tiny discovery to a real-world application, and understanding the whole system, not just your one little piece of it.
Okay, so once you have those mindsets in place, a future scientist needs the right set of tools to actually get things done. So this next group of traits, this is what we're calling the collaborative toolkit for modern discovery.
So what's the first tool in this new kit? It's being a pro at team science, because, let's be real, science is officially a team sport now. The biggest breakthroughs are happening where different fields crash into each other. That means a modern scientist has to be a great communicator and collaborator, someone who can manage projects with all sorts of different experts. The lone wolf? Yeah, that's a relic.
Next up is a skill that has become completely 100% non-negotiable.
Computational literacy. We live in an age of just massive data sets, right? So scientists have to be skilled with data science tools. Without these skills, it's pretty much impossible to design good studies, analyze the results, or make sure your work can be reproduced by others. This is as fundamental today as knowing how to use a microscope was a century ago.
And that whole idea of reproducibility leads us directly to the 5th trait.
Rigorous design? Look, this one is all about trust. Meticulous documentation, solid statistical methods, this is the bedrock of scientific credibility. It's this commitment that makes sure we're building progress on a solid foundation, not on shaky ground. Which brings us to our final group of traits. And these aren't just skills. These really get to the heart of a scientist's character and integrity, which, at the end of the day, is the ultimate foundation of public trust.
This first trait of character grounds all scientific work in a societal context.
Ethical reasoning. Scientific advancement can't happen in some kind of moral vacuum. It means you have to constantly think about the implications of your work, everything from data privacy to promoting equity. This alignment with what we as a society value is what keeps science in the service of humanity.
And finally, the trait that makes sure a scientist can thrive over a long, dynamic career:
Learner agency. The pace of change in science is just staggering. Knowledge is growing exponentially. This trait is all about being a self-directed, lifelong student, always ready to learn the next new thing. That's what keeps you relevant and effective for decades.
So there you have it, our 7 traits. But identifying them is one thing. Actually cultivating them is something else entirely. How do we build the scientists of the future? Well, the path forward seems to rely on 4 key pillars. It starts with an integrated curriculum, one that weaves these traits into every single course. Then, you need to assess people based on performance, testing their skills in realistic situations. This has to be backed up by mentored, hands-on learning. And finally, none of this is possible without access to top-notch resources and infrastructure.
And get this, these ideas are already in action at the highest levels. This quote shows that major funding bodies like the U.S. National Institutes of Health are building their training programs around this very ecosystem. They're actively working to develop these core competencies, which proves this isn't just a future idea, it's happening right now.
And the payoff here is huge for everyone. For the trainees, it means they get a complete skill set for a really successful career.
For universities and institutions, it's a blueprint for building world-class programs. And for the funders and really all of us, it means faster research outcomes and a scientific workforce that's truly ready for whatever challenges are coming next.
So we'll end with this question. The very nature of scientific discovery is changing right before our eyes. The real challenge is making sure that the way we train our next generation of scientists is evolving right along with it, so they're not just participants, but leaders of that change.